webcam on your computer. Last class we talked about just using videos, just showing a video. It turns out that using a webcam for our purposes is going to be just as easy. There's one very peculiar difference though, and it has something to do with security. What happens is when Google and the other browser people get together and they're designing how we're going to implement this video tag, they decided that they were nervous about the idea of letting someone's personal video camera, the webcam, go on and it transmitting over the web. So they decided they wanted to put some security into it. There's a thing called the Secure Socket Layer, SSL, and what it is it's a procedure that's used by when you have a web page. It's located on a host, and the hosts set this thing up. And what it is, it's supposed to provide more security for people at home, so that someone can't just come into your house and turn on your webcam and get it going and watch everything you're doing. Of course, the hackers can do that anyway. I mean, the real people that could do it can do it. Your webcam light, when it's on, doesn't necessarily mean the only time it's on. It can be, your webcam can be on when that light is off as well, by the way. You should know that, because it's the way they set up the controls. So it turns out that you don't even know when your webcam is on. And by the way, a corollary to that is you don't know when your microphone is on. So the microphone on the cam could be on, and the webcam could be on, or anything could be on and you wouldn't know it. People could be just monitoring you from some other place. But the SSL is supposed to help prevent that from happening using the video, using the techniques they've developed in the last few years. So what that means is it comes down to a simple problem. You guys don't have access to SSL. So what has to happen is you can't use Google's browser to watch. If you have a webcam program in your machine, you can run it and it will work. If you have your webcam program up on the web, up at Alta Vista, and you run it, it'll come back and it'll say you're prevented from running this if you're in Google. However, Foxfire hasn't get them mixed up with the book, hasn't implemented that. I don't know if they ever intend to or not, but any of the webcam programs that we write, you can actually watch in Firefox, and they'll work. Okay, at least they work on my Firefox, and I have a relatively new version, so I think it should work on all of them. So anything that you write that's a webcam type program, if you want to test it in your own machine till you're sure it works, fine, then upload it. But they're going to have to watch it in Firefox, or they're going to have to watch it in some browser other than Google's Chrome, because Chrome won't let them see what's going on, unless they save the file as a secure socket layer file, which is a special. The trouble is, we have a free service, and I don't think that free service will allow us to do that. I could write to them and ask them if they would give us a limited, because I use HostMonster, by the way, as my they host all my stuff, and they have one that I can use just to test it out. So they may have the same thing with Alta Vista. I'm not sure. If they do, I'll find out what it is, and then you could actually use it on them. But I didn't do that. So anyway, the long story is that you're going to have to watch whatever web. No, just web the webcam. It doesn't apply to any other videos. All the other videos work fine. It's when your webcam is on is when you have to have this done right. I'm going to introduce you to three things today, but one of them, among them, is the webcam. We'll talk about the webcam next time. But I'm going to start off with a different thing. The first thing is, there's a way for you to take any object you have on the screen and you can put it into orbit. You can make it go like that or go like this. Different sizes, make it go bigger or smaller in any spot where you want to do it. Okay. This is different than spinning. This is like the thing itself will actually move around the screen to a different location. So I want to show you how to do that, and that'll give you one more tool to design your web page. Okay, so this is like a basic. This is how to put things into a basic orbit around your screen. Okay. To begin with, you need an include file. orbit is the name of the glue file. It's up on my website. You can pull it down.
Is that orbit.js?
Is it .js? Thank you. You really are good. Good job. Okay, so that's the orbit is the name of the file. Don't forget, you can pull it down to your machine and upload it to Alta Vista or whatever. But that's the thing that contains the instructions for orbit. Okay. Now what has to happen is in your program, in your JavaScript, you have to call a function in that orbit that will actually do the calculations for you. Essentially all it does is it calculates the orbit stuff for you, the information. Okay. What you have to do is give it the information about what you want. What do you want to orbit? What object, what picture or whatever do you want to orbit? And you have to ask it how big is the radius of the orbit, where is the middle of it, and once you give it that information, it will, as soon as you hit that instruction, it will do it. It'll start doing it. So basically, that right there is what holds all the information. Then you get the program itself. I'm going to sort of write it in order here. Language. Yes. So, and I'm going to make the function first, because then I can describe all the stuff I have to describe. Do, they call this, and they call this do the orbit. Very unoriginal kinds of machines here. Okay. So this thing here is going to do the orbit for us as we do it. Basically, what I want to do is, I want the screen to have some object on it, and I want that object to go around in a circle someplace. Okay? The object's like a picture or something like that. Okay? The one in the demonstration program online used the wizard. The wizard flies around in a circle. He's a cartoon character. Okay, so I'm going to do the body over here first to get that stuff out of the way. Just want to put the picture there so you have all the things we need to do it. It's going to be this is going to introduce another idea which I haven't shown you before, but it's very handy for different things. I'm going to have it so that you can press a button. Press this button right here, and the thing will start spinning. You don't even see the character until you press the button. Then the character appears, and it's spinning. This is just to make the program run. That's all. Type the button. And value equals spin. That means the word spin right here is in that button. Spin is in that button right there. And on click equals that the orbit. There it is. So that's all that is, just the button. It sends it up to do the orbit here. Now, the picture itself, let me show you what it looks like. The source, in this case, the source is equal to, it's called wizard 1. It's a ping file. That's just where the picture comes from. And I gave it the name Wiz. That's W-I-Z, that's the name I gave to it. And it has a style sheet in here. And it had, the style sheet had position absolute. And that would make sense because when you want to orbit it, you want to orbit in a specific place. I want to say, 500. And top is 0. And here's a new one for you haven't seen before. Opacity. Colon 0 in this case. Opacity is a new word for us. If an object has an opacity of 0, it means you can't see it. It's invisible to you. If it has an opacity of 1, it's fully visible to you. If it has 0.5, it's transparent. 0.1, it's really transparent. So in other words, it's between 0 and 1 tells you how, if you have a photograph, for example, of something, you want to make it transparent, you just give its opacity something between 0 and 1, and it will make it relatively transparent, okay? So opacity is a new thing. Now notice what I'm doing here is I'm saying opacity 0. Here's the reason why. Because when the thing starts off, it's going to put the character in the position I want it, right here. It's going to put it in this position. I could do that. If I didn't put that opacity thing here, the character would appear in that position, okay? By making opacity 0, what I've done is I'm saying don't put this character on the screen until you put it into orbit. So basically what I do is I say opacity 0, and then up here, in the orbit, up here, I bring the thing to life. I say, this is the character they want to orbit, so they bring it to life. And so what I do is I change its opacity to 1, and then I make it run. So in other words, by making it 0 in this particular program, this is not an all program, this is in the orbit program, I make it 0 because I know that this guy's going to bring it to 1 before it starts to show the thing. Or, the alternative is, if you don't trust that, which you shouldn't ever trust anything, is to actually intentionally yourself set it to 1. Okay? So in other words, before it goes into orbit, you can say, I want to set this thing to 1. You can do that. So if that didn't do it, you would do it physically up here in this function. So what I'm going to do is I'm going to change it to 1 in the function to be sure it's 1. I want it to be visible. I don't want it to be visible before it's orbiting, but as soon as it starts to orbit, I want it to be visible. So what I'll do is I'll make it visible, and then I'll go into orbit. I'll say, take this into orbit now that it's visible. Okay. So up here, now that far, that takes care of the image, and I think that's the program /body /HTML. So in this particular program, I now have, if it ran just that right there, as soon as you run the program, you're going to see the button, but you're not going to see the character. You're not going to see anything, just a button. It says spin. When you hit that spin button, I'm going to go up to my program. The first thing I'm going to do, now, the idea of this thing is whiz. So I say whiz.style.opacity equals 1. So what I've done there is I'm saying turn on the visibility, make it visible. Okay, it's opaque, you can't see through it, so it's visible. That's what happens. Okay, so the first thing I do is that, and then I go up to the function that's inside orbit, and actually say, now put the character into orbit. Now here's what you have to do. I'm going to start over here. It's not enough room to write, so I'm going to start over here. This line goes right here. Okay, this is a function. There's a function up there. And in the function, you have to send a bunch of arguments. Okay, and here are the arguments that you have to send. First thing is the name of the function that you want to use. It's called start orbit. Start orbit, all one word, no caps. This is a function. It's in orbit. Okay, start orbit. The first thing you do is you send it the name. You send the name of this guy right here. That thing. It has to know that. But you can't just send whiz. What you have to send it is, quote, whiz, like so. You send it the name of the object. Okay, that's his name. Okay? The next thing you send it, comma, is the center point. Where is the center of the orbit? In other words, in this case, you want to send it this thing right here. What's it going to orbit around? So in this case, I made it 500 in the x direction and 500 in the y direction. In other words, that's the center. 500x, 500y is the center of the orbit. That's what it's going to be. And the next thing I wanted to say is, what is the radius of the orbit? how big is this orbit going to be around the center right here? How big is it going to be? That radius here, what is it? I'm making it 600, let's see if I did this right, it's 600 pixels. Did I do that? No, 300, 600, sorry, I think I did this wrong. I made this 600 right here, I thought that was too big. This is 500, 600 is the X and Y. And then I made the radius 200, yeah, it's smaller, so I thought. The radius is 200 pixels, so that's the radius. So this is the X position and the Y position of the center of the orbit, and this is the length of the radius right here. And then, do you remember in our all of our programs that have a timing thing involved in it, the set time thing? Well, what happens is each one of them is using a speed variable. It tells it how fast to go. I use these around 30 is about what I standardly use. But that's the variable we have to put in now, is how fast we want this thing to go. Don't forget, the bigger the number, the slower the speed. So if you put 1 in there, it's going to go as fast as it possibly can go. If you put 30 in, it's about normal for what we do. If you put 100 in there, it's going to go slower and slower. In other words, it takes that many milliseconds before it runs again. And then you increase the number, it's slower and slower because it takes a lot of milliseconds before it makes the next frame. So therefore, what I did is I put in, you can put in a standard, you can put in 30, just a standard if you want to. And that's the speed. And finally, the last thing you got to put in is either a +1 or a -1. What that tells it is a +1 moves like normally move counterclockwise. +1 does that, and -1 does this, and move in the other direction. So you, in this case right here, it's going to go that way, in that direction right there, it's -1. And that's it. That's the function. It's a lot of stuff you got to send it, but that's all you have to do. And then it does all the orbit calculations and timing and everything. So you send it the object that's going to be rotated, the X and Y of the center point, the radius, the speed that you want it to go at, and then minus or +1 to tell it which direction you're going to have it rotate the orbit. And that does it. That actually does it for you. Then you can, at that point, we close this thing. And I believe that's in /script /head. That program will do it. And that's how you create an orbit, okay? Now I have to admit, this is not the most sophisticated program that you've ever seen, but it's an idea that allows you to do something that you might want to do for some purpose in your programs. And so I want to give it the ability to do it without you having to do, behind this thing is some trig functions, like you have to use the sine and the cosine, and you may not have had trig, and it's a bunch of stuff. So I said, okay, I'll just set this thing up, and then it'll work for you. And it works pretty good. I've tried it on several different things, and it works out pretty well. But it isn't sophisticated for this point. It won't allow you to put 2 things in orbit. Only one thing can go into orbit. If you want to do 2, I'll reset it up for you. If you need that desperately, I'll do it for you. But it was much easier just for me to throw this up to get it to work. So that way, at least you have the capacity to orbit things. And that can be handy. There's various things that you want to put into orbit. Another way to orbit things, by the way, if you think about it, another way is to have a big white circle with an object painted on it, like, you know, have your image, a big white circle or with an object on it, and then you simply do the rotation. And of course, you won't see the white, so it'll just look like the thing is in orbit. You can orbit that way too. That's a fake way of doing it. Trouble with that is you can't have anything in the middle unless it's brought forward in the z-plane because it's going to spin with it. So you have to have it. It's a little bit of work, but this will give you something to work with that you can start with. The opacity thing is probably one of the critical things that I brought up here. This thing right here is something we haven't talked about before, and it is interesting that you can make any object, including your videos, by the way. You can have the videos fade in, for example, or fade out, or whatever. You have the capability of doing that. It's kind of an interesting possibility. It's a tool. The idea is you have some kind of tool to work with, okay? Any questions about this at all? Figure it out? Okay, let's go to the next thing. Next thing is something I talked about a few times, and I just want to, let me just do a diagrammatic way of saying it before I actually do it. There's a program up there, you probably saw it with the Star Trek transporter room. Did you see that one? It's dark in the transporter room, and basically what happens is the transporter goes on, and the beam comes on, and the character appears. The way that works is this. When you first look at the thing, it's just the transporter room. And then what happens is, all of a sudden the sound starts, that noise that comes with the transporter that has a certain transporter sound. And then what happens is, what fades in is the ray that comes down, plus the character. And then what happens is, you turn off the ray, leave the character there. So in other words, it has different stages. Make the sound go, bring in the ray and the character, kill the ray. So in other words, you get three different functions. They do one thing after the other. And that's something that I just wanted to take a little diversion here. All of the systems you use, all of Microsoft, every single system you use works in this way. This is the way they work. They say, do something, do this, do that, do the other. And there's a huge number of these things. Do. And what happens is, they loop through these things over and over and over again. That's how all programs work. This is the basis of how they all work. They say, look for this, look for that, do this, 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 do this. For example, on your computer, how does the thing know when you press the mouse? The reason why it knows is because it's going and saying, did they press the mouse? Did they do this? Did they do that? Did they do the other thing? Did they press the mouse? Did they do this? Did that? Did the other thing? And as soon as they hit the instruction, did they hit the mouse? It jumps over to what to do when the mouse has been pressed down, or when a key has been pressed down. So all these programs all have this thing that is cycling. And then what happens is, all these if statements say, if you do this, if you do that, if you do any thing, then you jump over to do that thing, or you jump over to do this thing. In other words, you jump over to do the thing you do, and then you come back. So essentially what happens is the computer is able to go and do all these so fast you don't even notice it. But it's checking the keyboard, it's checking the mouse, it's looking to see what your program is supposed to do, and it looks at everything. But it looks at it one after the other, and it goes to a function to handle all these things, okay? What I'm doing with this function idea, rather than giving you this loop right here, because we don't have a loop yet, we don't have a way to really do that, I haven't shown you any of that. So basically what I'm doing is I'm saying, instead of doing it the way they're doing it, what I'm saying is this: take this function right here, actually this function right here, and do it, and then jump to this function and do this one, and then jump to this function and do this one. So what I'm doing is I'm just making up a simple sequence of functions that you do one after the other, okay? By the next few weeks, we'll have one of these guys, where it'll simply say, when you go from your HTML, you jump up to the first function, and what that function will be is one great big loop that'll be looping you through other functions, saying do this, do that, do this, do this, do this, do this. So it's just like a little strategy that everybody uses. Okay, so for now though, let's start off with a simple one. It simply says cascade these things. This goes from here to here to here. This one makes the sound. This one fades in the character and the ray. This one kills the ray and the character just remains standing there. So in other words, these functions, you jump to them one after the other. And what happens is you have a timing thing in each one, telling it how long do you do this, how long do you do this, how long do you do this. And as you may recall, we have this thing called set timeout, which simply does it. Now let me talk about set timeout. We talked about it before. There's different ways of dealing with it. It's actually, it is actually a relatively new idea in this language too. There were different ways of doing this, and they settled on it because it kind of works well. You got a function here. Let's say you have this function, and it just does something, whatever. And then you have this set timeout right here. Blah blah, and you have some period of time or whatever. Okay, so what set timeout does is just go back and do this every 30 seconds, or 30 milliseconds or something like that. So what happens is you run the function, it goes down, it does whatever you want to do, whatever instructions you want to do in here, then it bumps into this thing. And what this thing does says, I want to come back to this function here in 30 milliseconds. So it sets this thing, it goes right through and ends. The function ends, completely does its job, it does everything it's supposed to do. But meantime, in another thread over here, you got this thing counting up to 30 milliseconds. And as soon as it hits 30 milliseconds, it jumps back into this function and does it again. So in other words, what is a little delay, we have a system delaying in a different thread. Well, the thing is that if, supposing I want to go into this function and I want to come out of it, and I don't want it to run again, I want it to stop running, okay, how would you do that? Well, the easiest thing is, remember, every time you come in, it does what you want to do, then it sets the function, and then when it's finished, it comes back in again, and it sets the function. So in other words, what happens is every time you hit this, it sets it to re-enter again. But if you don't hit that, it's not going to re-enter. It can't do it again. So what you do up here is you say, well, have a counter of some kind. Like, have this thing called a count outside the function, equals 0. And then what you do is say count equals count plus 1. And then you can say right here, if that counter is equal to whatever number you want, 30, 50, 90, 20, whatever we want, go to return. And what that does is this. It says, it adds 1 to the counter. It says, am I at 50 yet? That means you've gone around 50 times. If it says yes, it's an if statement. Then what you say is return. So in other words, in these curly you say return, that's all. And what it'll do is it'll jump out and it'll never hit this again. So in other words, once it jumps out, that counter never goes, timeout never goes again. So in other words, timeout keeps going, it'll keep bumping into it, doing it, falling through, until you say, don't hit this. Return, right here, you say, if the counter, if count is equal to some number, let's say 40, then what you do is return. Get out of here. Don't do any more. And what that does is, that causes this thing to hit this and bounce out, and it never hits that instruction, therefore it never sets it again, and you're out. Okay? So here's what I do. I set up these 3 functions in a row, and they're like this. And what I do is I say, have a counter up here, and I do whatever I want to do, and here's the set timeout right here. And when I do whatever I want to do, and then I check to see if I'm supposed to be still here. If I'm not supposed to be here anymore, what I do is I jump to this function right here. I get out by I don't return, I just simply go to a different function. I get out of it. Now, here's where you got to be careful. This is why you still have to put the return up here. In other words, you have to write, if for example, supposing this is it right here, and I want to go to another function called banana. So what I do is I say, okay, I've hit 40 in the first function, now I want to go to banana. So I say, well, banana, do that. It'll go to banana. It will do it for me. It'll jump down to the next function, okay? But here's the problem. When that function finishes, it comes back to here again, and then it will fall through, and it'll hit this. So you still hit it. So here's what you have to do. You say, go to banana, and then you say return, right there. And what that does is this. Here's the sequence of events. You call this function. It goes through, keeps hitting the restart, it keeps resetting and retiming it, rather. It goes blah, 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 blah. And finally it hits this number that you want, and it jumps out and says, oh yeah, I've hit 40, so go to banana, which is the second function right here. It starts to do it, but when it returns from this function, it returns right to here, and then it hits a return immediately, so it never hits the timeout again. You don't want to hit that the second time. So you basically, another time, you want to avoid that. And that return is the way you exit to get out of the thing. If you don't have a subsequent thing, and you just want to run this a certain number of times and then quit, then all you simply have to do is have, if it's 40, then just return. In other words, you just get out of it. You don't go to another function, you just get out of here, that's all. So in other words, once you get into a function, that thing will keep you locked into it. It will keep putting you back into it again. We don't want to do that. You have to do something spectacular, okay? So that's the basic strategy I'm using to run these functions. Let me show you. The one that I've got here, I'm not going to write the whole program, but I'll write the part that talks about these functions. Here's what happens. The program says, make a noise, the buzzing sound of the transporter. And by the way, when you get out of the function, that noise continues. That's an external thing. Once you say make that noise, just by jumping out of that function won't stop the noise. The noise still keeps going. It'll go till it's over. Okay, because it's like a different thread also. It says, make a noise, and you can do something else, and it's still making its noise, okay? So, what happens is they have this function called transporter right here. Don't forget, I've got all the JavaScript stuff here and everything, but this is just the function. This transporter. And all its job is to turn the noise on. And the noise, I gave it some, okay, it's, I gave it the name sound T. Sound T dot play, open shut, that right there. No, what that does is that says, let's make the noise. And the noise is called sound T, and I have it out there, and I have used all the audio stuff to get it in. Okay, we have other programs that do that. But basically at this point, sound T is the variable in JavaScript that we use it. Okay, now, next question is, this is over. As soon as I say play the noise, I want to now jump to the process of making the beam come in and the character come in. I'm going to change their opacity. See, they came in, they were opaque. They were not opaque, they were transparent, they were 0. So therefore what happens is I want to change that 0 to 1 now, I want to bring them in. And they're already on the screen, but they're not visible, so I want to make them visible. The only thing that's on the screen at this point is the background, is the image of the transporter. That's all that's there. So then what you do is you go to the second function, and that one's called beam on, like that, and this is closed. So here's what happens. It plays the noise, goes to beam on, and it comes out of here, just like so, okay? Now, notice this thing up here doesn't have any kind of repeat. It doesn't repeat at all. Okay, there's no repeating it. So to play the sound, it'll go to beam on, and when it comes back to beam on, it'll just stop. It's over. The program's over. Okay, but now what I want to do is I want to put the beam on function, which draws in, which changes the opacity of the stuff. So I have another function down here, and it's called beam on. And this is where this goes. It jumps over to here. This thing jumps right down to this function here, different function, okay? And in that function, I do have counters and stuff. So I say, first of all, I say if the count. This is sort of a generic thing, but is greater than or equal to. Whoops! I use 1 here. Yes. Oh, this I want to go to beam off. Function. And I want to return. I'll explain the return in a second here. It's the same reasoning that I used above. I say count. Now, we talked about this last class, but I want to bring it back again. If you say plus equals 1, what happens is every time it hits this instruction, count will get bigger and bigger and bigger. It's like saying count equals count plus 1. This is an identical statement to it. It's just a shorthand that computing people have gotten over the years. They've developed it. And so this thing right here simply says add a 1 to counter. So that count is going to be 1 bigger. Every time it hits this thing, it's going to be 1 bigger. So it keeps counting, in other words. Then what I'm going to do is count itself is located outside here. Variable count. You've got to have it outside the function because you don't want to have it inside the function because this thing has to be careful. It has to not reset. You want it to, every count that you put in, you want it to stay there as you come back in again. You want it to still be there. So you have to count outside. Okay, next thing is count plus 1. And then what I do is I say, the character that's transported down is Donald Trump, by the way. So I call him Don. I give it the name Don. He's the actual image that comes in. So I say, well, Don, that's the image ID dot style dot opacity is equal to, I'm going back to count here. I'm going to change this to 0.1. So I'm going to change that to 0.1. The reason why is because it has to go, the opacity goes between 0 and 1. So I want to keep adding 0.1 to the thing. So it goes from 0 to 0.1 to 0.2 to 0.3. And it gets darker and darker. It gets darker and darker, more opaque. So therefore, that's should be 0.1 right there. 1 is right. Pardon me, I made a mistake. When he's greater than or equal to 1 means he's all there. And so, but right here is where you add over 0.1. So I'm going to take this count over that 0.1 to it. Then it's going to be 0.2, 0.3, 0.4. So it's getting more and more opaque. And I'm going to say equals count right here. And what that's doing is, the first time through, he'll be 0.1. It'll be slightly more than 0. And then the next time through, it'll be 0.2. So it'll be slightly darker and darker and darker. So as you add 0.1, he's going to keep getting darker and darker. So he's going to come in. He's going to appear. At the same time as he appears, you've got another thing running. It's called trans. Trans is the transporter That's the name I gave to the image of the transporter beam. I could have called it beam or something else. Bit style also, dot opacity is equal to count also. So it's both Donald and the beam come in at the same time. They both come in at the same time. They get darker and darker. And finally, at some point, this thing happens is, this is the end of the function right here. At some point, what happens is, this thing finally goes to 1. Note you've added 1.1 plus 0.1 plus 0.1. Finally, it comes in and it's 1. And when it's 1, you want to jump out of this thing. So you say, well, when it's 1, go to beam off, which is the next function. It's the next function. So you have a function called beam off. And that function, its purpose is just to shut the thing off. So I simply say trans, which is that thing right there, trans.style dot opacity equals 0. Done. So basically what I'm doing is I'm saying turn the beam off. Donald is going to be there still, but the beam is going to be off. So function 1 makes the noise. Function 2 increases the visibility of Donald Trump and of the beam. And function 3 just shuts the beam off and leaves Donald there. He's what remains. And so that's kind of why you have these 3 functions in a row cascading down. Okay, this is like a way of getting you to have a sequence of events that are different than each other. So you don't just keep doing the same event over and over again. You're doing something, then something else, and something else. No, there's a story in the sequence of events, as well as in the storyline that you're developing. And I just want to give you that strategy. This thing right here, the important thing about this is when you turn on the sound, it doesn't care about the program anymore. It's going to continue that sound unless you turn it off. If I said sound t.pause, I could shut it off, but I don't want to do that. Turn it on, get out of its way, go to these 2 characters and you start bringing them in. So I bring them in, and at some point I reach 1, and then jump over and I say turn off the front one, so the front one disappears and all you got is Trump left in the background of the transporter. This is the program that's online, and this is the basic part of it. The other stuff is things you've seen before. Just remember the opacity thing. That's a useful thing, and there's a lot of ways of using it, but this is a program that kind of does it, so it's kind of fun. Okay. With those things out of the way, let me go to the webcam, which is the thing we want to get to today for sure. As I say, this isn't the whole program, but the whole program is online. It's one of the programs of the day. Okay. Now the thing is, if you wanted to turn on, like I say, if you run your webcam and this program is in your machine, it'll run fine. If it's up online at your Alta Vista, it will not run fine unless you run it in Firefox. Okay. If you run it in Chrome, it won't run because they won't let you run it. If you have a purchased website up there, host, then they may have the ability for you to do it, a secure socket layer, and they'll tell you how to do it. Essentially what you have to do is you have to give it, normally you give the name of a file, you say Alta Vista and dot the name of your file, whatever it is, and slash the name of your file. But in the case of when you have SSL, it's different. Then you have to give it a special name, and it says HTTPS. Have you seen that? On HTTPS comes up instead of HTTP up in the front of the thing. That means secure. Question?
Usually we use Chrome, but in this case we use Firefox.
When you what?
Usually we use Chrome, but in this case we have to use Firefox.
Yeah, in this case. This is one case. That's because of the security they have on it. Like I say, you don't have to, if you run one of my programs, you don't have to because I have it on secure socket layer. So in other words, my demonstration program should run for you if I gave you the right name for them. But they probably, the ones I give you today won't because they're so simple, I just put them up there. I want you to have the exact code that you'd use. If I put secure socket, it would look different. It wouldn't look, I like to have exactly what you're going to say. So this one's called the easiest webcam, and it is the easiest webcam. Okay, and you've got head. you have an include file, a script file. And it says mini webcam. If you read it on, there's a W in here. Okay. Sometimes you can make, if you forget something, the thing is forgiving. You never know what it's going to forgive you for, though. If you forgot this right here, believe it or not, the thing would actually forgive you, it would still run. But always put the things in, never take a chance on it, because you want to be sure that it runs. So always add, this stuff right here should always be, if you didn't put that in, this might run, probably it will. Again, it's one of those things where they give you some options that I wish they never gave anybody. Okay, then you're in the body. And then the video thing was like this, video slash video. Nothing there. That's it. Pretty easy program, huh? And that will, if you run that on your own machine, it'll work. Your camera should go on. Anybody doing it here?
It works here.
And it should work if you put it online. If you upload it to Alta Vista and you run it with, tell me if your browser is different than the regular. Are you using Chrome?
Well, I opened up the program in Firefox and it worked.
And it works. You have you have 3 browsers, right?
I've got Safari, Firefox, and Chrome.
Yeah, try Safari, see what it does. I'm kind of curious. So I want to see if they put the security on yet. Anyone got Opera? No? Okay. So there you go. That's it. It looks pretty easy, doesn't it? It's actually pretty simple. The whole trick is this thing, all the work is done by this guy right here. That's the thing that turns on your webcam and does all the necessary work to organize it. Okay. That's the easiest, that's the very easiest one. Now the trouble with this one, the trouble with this program is that you don't have any controls over the size of it or anything else. You're just telling it just to operate. But you can control it. You can tell it what, you can make the controls work yourself if you want to. So for example, suppose you wanted to say, I want the picture in a certain position and I want it a certain size. You can do that. I'm going to do it right now. All you have to do is change this line right here and give it some substance. Okay. Supposing I say video, then I say style right away. I'm going to give it a style.
It doesn't seem to be working for Safari.
What?
It doesn't seem to be working
It
for
doesn't.
Safari.
Okay, so they're up to date. So Firefox is the only one that actually will allow you to see this stuff without having the security or anything. Thanks. Now remember, what I'm doing here is I want to tell the image. I want to tell it where to be and how big to be. Okay. Remember, the ratio is always this right here. It's always 4 to 3. And the images we're using in our system here. I built this to a certain standard and left it like that. Left at 400. Top at 200. And width at 400. Now, I have to ask you a question here. is this image going to be on the screen? What'd you guess? It's going to automatically come in at that ratio that you have to have. And if you have a width of
300?
It'd be 300, yeah.
Okay.
400, 300. So no, you're told that the width is 400, and it maintains that ratio of 4 to 3. So if that's 400, that'll become 300 right away. So that's how it works for you. Well, if you just put a width in, it'll calculate what the height is of the thing. You can tell it the height if you want to. It gets very confusing in the thing in video because it has to have certain ratios. It doesn't like screwing around. And depending on what browser you use, these guys implement them in different ways, so you don't know what they're going to do. If you just give it the width, that's the best way. Give it the width, and the height will calculate itself, and that takes care of it for you. Okay, and that's it. So now what happens is, if you had any kind of a function, no matter where it was up above, you can change this, and you can change that. You can move it around. You can change this too, but this thing's a little bit touchy about changing, as I mentioned last class. Because what we're dealing with here is a frame and an image, and it gets complicated when you try to deal with that complication. When you move the thing, it's easy. It moves both of them the same, and they both go properly in the same direction. When you change the width, it gets flaky. It gets kind of weird. So dynamically, you don't want to change the width unless if you read up on it and you find out what the current situation is, you can figure it out. But next year, that situation may be different, so you've got to be careful when you start dealing with things that if they look flaky to you, and your code is right, then you have to say, oh, something's weird here. They haven't quite got this right. Then you go into look at the technos, what they say about it, and they're all arguing with each other about what it should be and all that, so you finally say, forget that. Don't want to do it. So there it is. That's it. That is again, that will show you your... Now, there's one more thing I want to show you here. It's just kind of, it's sort of cornball in a way, but it isn't. It actually has actually usefulness. There are things that you can do with this. First of all, you all have cameras, and you know that your cameras will, if you want to, you can have it outline faces of people. They can put rectangles around faces of people. Well, we can do that too. We can put rectangles around people's faces. But even better than that, for fun, we can put mustaches on them and whatever you want. So in other words, the webcam's running, the camera's on them, and here's their picture right here. And they look at it on the screen, they see themselves on the screen right here. And if you want to, you can add a mustache to them. And even when they move around, the mustache will stay with them, no matter where they move. Because it's locked on their face, it knows where their face is, and it simply calculates where's this thing going to go when they go in a certain direction. What I have here on the one we've demonstrated, on the one demonstration program I have, I left the thing right here at, if you look at the program, it has a width of 20 pixels and 20 pixels high. That's how big it is. It's made 2020, so it's made like that. And it's not pixels really, it's a different measure, but 20 by 20 is what it comes down to. Actually, the number of pixels in the image is like, I think it's 171 pixels by 171 or something like that. But it doesn't make any difference. Here's the point. The point is, if these numbers I have on this program, if you look at the program, when you look at the one that's that shows you the mustaches and everything, you'll see that I have a variable. I have a little, no function up here, but I have variables I've defined up in JavaScript. One of them is box left. One of them is box top. The other one is box width, and the other one's box height. What that tells you is how big this box is right here. So when I tell you what the left side is, the height here, and I also tell you what its width is and what its height is here. So it's left, top, width, height. I give you those four numbers here, okay? And they're locked up into this thing called webcam head, which I'll show you in a second. So the point is this, that suppose you want to put ears on this guy. What you'd have to do is you'd have to make the box bigger, okay? And the ears have to be, everything has to be drawn inside the box. Whatever the size of the box is, you draw it inside the box. And then you tell the program, like, instead of being 20, you might want this to be 40 wide. You might double it or something. And then when the box prints, it finds the face, but the box gets wider, and it puts, any picture you put, it'll drop it right on top of this thing. Okay, I'm going to write the program in a second here, but basically, that's the idea, is you can change the, like you want to put a beard on it, for example, you might want to drop the box down this way. Now, you got to be careful, because if you just make the box bigger, here's what happens. When you make the box bigger, it'll slide over this way, it'll slide over this way. In other words, you made it bigger, it just slides over. So what you want to do is, you've got control over the left side, so you move the left this way to compensate for that. Basically what you do is, however wider you make, go half as much back this way to make sure that it doesn't just go like that. Make sure that it slides back into position. So in other words, if I made this thing, if I went from 20, if I went to 60, for example, so I just added 40 to it, I would say make the left-hand side 40 less than it was before. If it was 80, I'd make it 40 less. I say 80, if I said, yeah, no, 40, I'm sorry, make it 20 less. In this case right here, if I'm going to 60, that's 20 is 40. So it's 40, you've added 40 to the width here. And what you do is you go back 20, and it'll bring the box back to the middle. So well, you've got to be careful if you're going to put a beard on somebody or glasses or whatever you do. You've got to be sure that your image has got enough room to drop that thing in. So what you simply do is to put an image on something, it's very simple. You go to Paint, like the Paint program, for example, and suppose you want to put glasses on the character. You say, okay, draw some glasses that you think are going to be funny or whatever. And then what you do is, by the way, this color right here, if I were you, I would make it some color like red or some other color than white. Don't make it white, make it some other color. So you're in Paint now, you made these different colors. Then what you do is you go like so, or however big you think the face is. Just guess it, just take your mouse and grab the thing and copy the whole thing over to X in view. Now you're in X in view, and it looks like this. And what you do is you make this transparent, and now you have this thing right here, which you still can see. Now what you do is, in X in view, you can also make the width and height equal. It doesn't mean it's what it is. Give it any width and height you want. It doesn't make any difference. It could be 50 by 50 or anything by anything, because the program compensates for that. It doesn't care how big you make it. It cares how big you tell it you want it to be on the screen. These numbers here are what determines how big it's really going to be. So basically what you do is you make it approximately square, exactly square. And if it's exactly square, the original box will fit it right over the original box. It will simply go right in. It'll be over here, which is 20 by 20. It'll go right into that and fit right into it, okay? As long as these things are equal, here and here. So now what happens is, suppose you want to put ears on it, though. Now you've got a different situation. Then what you do is, you decide the ratio that you want it to be. You say, okay, I want it to be, it's going to have ears on it, so I want it to be like twice as wide as it is tall. So if you make this like, in this direction you make it like 100, and you make it 50 in this direction, that's, twice as wide as it is tall. And then you put the ears on it wherever they're going to be, and then you say, okay, that's what I want. You put that into X in view, get rid of all the extra space, and then over here, what you do is you change these numbers. You change these numbers here to account for that double size, and then when you run the thing, that double size image, which will fit right into here, and the ears will go. You have to adjust it a little bit. It's always adjustment. You have to, like, it's sort of an art problem. You have to make it bigger or smaller depending on how big the thing is. But you'll be able to figure it out once you do one of them. You get to see how it works. But let me write this program. It's not very big. And I'll show you. It shows you how to actually put faces on it. And again, this program shouldn't run in, it shouldn't run in Chrome, but it might. Did you run the last program? See if the last one on the list runs.
Is it the mustache one?
Yeah.
I ran it in Firefox. It worked.
Try running Chrome, see if it works.
It didn't work.
It didn't. Okay. Okay, you tried it.
It works in Firefox.
It works in Firefox. Yeah. I know they work in Firefox. Okay. But let me write that program and talk about what these things are again. So you want to use this thing. Same old thing. HTML. Now the script is, you got to be careful. It's not just using the regular webcam script. Because it has all this other of stuff in it too. Whoops, wrong way. Yeah. Source equals. I call this one webcam head. I remember it this time. Here we go. /script. There it is. And that, what that does is, that'll bring in the things that you need to put this, to add additional things to the virtual things to the face, okay? Don't forget, this thing, what it automatically does, without any further ado, it actually locates the face. It locates that face.
So I'm looking on the code that you have for this program, and whenever there's like a .js thing, it links it to like the text JavaScript document that you have there. But on this one, it's like a document.write, and it lists a bunch of things that are attached to your Dartworks website. And I'm not sure like if that's...
because you went, what you do is take those things and put them in a file and give it the name of that file, give it the name webcam head, .js.
I'm just questioning like...
Why that's true?
Well, no, it sort of depends on like your website, because it's...
Yes. Okay, if you want to
everything is through your
do
website.
it, you can grab each one of those files. No, that's not going to work. That's not going to work. Here's the reason why. What happens is, it's calling things from libraries there, and the trouble with those libraries is they often call other files within their own libraries. So in other words, what we see there isn't all it's used. This turns out to be quite a complicated problem because they have many files involved in this thing. And that's the reason why you see what you see.
Mm-hmm.
So instead of calling one thing, I couldn't do it. I had to call dozens of things. So I said, okay, I'll break it down to these 4, and I'll go on my website. I have all of their libraries. So in other words, if they call something to another thing, I have everything there. They can call it. Okay.
So we would essentially be using like a document written by a like cache of programs that you've already like
Yes.
created for us.
Now, what I should tell you to do though, which you experiment if you want to, look at the 4 programs it shows there, okay? And no, it has libraries and things. It has like folders and stuff like that. You could just try to put those in and see if it works. In other words, so when you say source, put this source, and then that source, and this source, put a bunch of sources in there and see if it works for you. It might not, because it might require things that they don't directly go to. I could experiment with that if you want to. I can do it because I know how it works. I could take a crack at it and see if it works, but if it didn't, the alternative is I could find the original site for you, and maybe they have the stuff we need to do it. Here's where the trouble comes in with these graphics things. It'll be true in our 3-dimensional graphics, so we get to that too. They have, things are never easy at this level because these are things that have just barely been developed. So what they do is they have their own folders where stuff is in them, and it isn't built on, it isn't in the browser, it's something extra. So you have to go to their folders and grab stuff out and use it. But sometimes the stuff in their folders uses other stuff in their folders, and you don't see that. You may pull a program perfectly good, but that program uses more, it's like it got includes of its own, which go all the places. So you get locked up in this thing where you got maybe 20, 30, 40, 50 programs that you have to account for. And it's very hard to do that. What I've tried to do is trim it by putting everything on my site and leaving it there so you can use it. It's always going to be there, by the way, unless somebody, this will always be there. And it's always available to you. So if that's the safe part, because this site's going to be there forever. Other than that, I think that it's not going to be. If you find somebody who's really good at this stuff, who knows how to do programming, they might be able to pull it for you, move it to new place. Anyway, so let's go on with this thing as it is. Next thing I'm going to make the script language here. Script language equals JavaScript. Because I'm going to write some code. I'm not going to write any actual code. What I'm going to write is some variable names. One of them is going to be box left. They defined it, so I'm giving it a value. They defined it up above, but I'm giving it the value here. Box left equals -10. Box top equals 0. Box width This is not a function. There's no function here at all. This script. Slash head. Okay. And then the body of the thing, I gave it a, in the program I said style, I gave it a style. For no reason other than to make it look good. Puts the image in the middle of it, which makes kind of sense. And then I put down the video. This is, what this video is going to be, by the way, is from your webcam. It comes from your webcam. I'll give it the name video. That was the ID, but it's also a video. I gave it that name. That's all. The image. Now, this is the image of the mustache or whatever it is. This thing that you save here. When you built this rectangular thing, you have to build it someplace, and then you give it a name, and whatever that name is a source, whatever it is. The source is whatever name you give it. I'll call it frame. Give me a frame, and the ID equals this has to be this. You have no choice. Whatever you use for an object has to be called glasses. That's the name it has to be given. Okay, you save it with that name. I'm sorry. You save it with that. You save it with the name you want. You have to call it that name in the ID, because what happens is up in that program up here, I've got it set up to accept that. Otherwise, you'd have to send the name glasses to it, and you could do that, but it's a nuisance. This way, you just use the same name and it works. So use the name glasses all the time. Use any name you want in your this is .jpg or no, it's not a JPEG. It's a PNG. That's a PNG file right there. So this is your source, whatever it is, and that right, the ID is called glasses. And then the style. Now this is again where opacity comes in. Position absolute. And opacity (0). Opacity is 0. Position absolute, opacity is 0. We don't say anything about left, right, or whatever, because these guys control all that. This controls the height, the width, where the top is, and where the left is. The box lays over the picture based on whatever you tell it. Okay. So there it is. That's the thing. We finish off the program /body /HTML. And here's what happens. You run the program, and it will show you the picture of the character, and it'll show you the mustache or whatever in front of it. It'll come up in front of it, depending on what you put up there. And these guys here determine how big the mustache is and where it is exactly. That determines that. And once you determine that, by the way, where it is and everything, that isn't, the reason why this is such a weird deal is because when the guy moves his head, the mustache moves with him. See, and there's a lot of code behind that to keep track of where he is and where the mustache is. And it's not perfect. It wiggles a little bit. It does funny things, but it can be used for fun stuff.